evening, everyone. So welcome to our ASP Astronomical Society. We are ASP. We are from ASP Astronomical Society of Penang. This is our monthly APOD virtual tour session, which we will introduce selected photos from the APOD website. And APOD stands for Astronomy Picture of the Day. This is a website actually it's a website provided by NASA and Michigan Technological Universities. So every day they will upload astronomy related photos. And today, so every last Saturday of the month, all right, we from ASP Astronomical Society of Penang will share our thoughts, and we share a little bit information about selected photos of APOD every month. So a simple self-introduction. So I'm Lai, a committee member from Astronomical Society of Penang, and I believe our audience always see my face in a lot of live session. All right, and together with us tonight we have Dr. Chong Hon Yu, our president of Astronomical Society of Penang. He is actively involved in a lot of outreach activities conducted by ASP, and I believe also all of our audience are familiar with Dr. Chong. So say hi to Dr. Chong.
Hello, everyone.
And also today we have two friends from our society. It's our very, very young member. All right. First we have Ryan. He's 13 years old this year. All right. Also, he have a great interest in astronomy, and he also actively joining us for a lot of activities. And also we have Marcus Chill. Hi, Marcus. All right, Marcus is also 13 years old this year, and is also our young member. Also, very keen in joining us and join a lot of activities together with us in Penang. So today, without wasting time, so let's start with the APOD today on the 27th of February. Yeah, so I'll pass it to Dr. Chong, and just to add on a little bit, the APOD for February actually it seems like it have a theme. Is more related to aerospace for APOD February. If you go through all the APOD pictures in February, you will realize that most of the photos are related, especially the Perseverance rover. So I'll pass it to Dr. Chong for the APOD today.
Thank you, Mr. Ryan. So Ryan, prepare for Perseverance. A lot of pictures you are going to present. Okay. So we go to the first picture is for I present. Okay. Wait a minute. So can you see my page live?
Yes.
Okay. So 2021 February 27 again. You look here. All right. Now before that, I will just repeat a bit, add on to what Lai said. You look below every day. Please, if you want to send a picture to airport, you have to be good to two guys called Dr. Robert Nemirov and Dr. Jerry Bonnell from America. They are the one who select a picture to put in. All right. So let's go to February 27. Today. A bit slow. Okay. So this is it. February 27. Wow. You have two craters. Wow. You have the picture of this Perseverance rover landed here on the surface of Mars, and then the descent stage is here, parachute is here, and heat shield here. So basically, this is a picture of the Perseverance landing site from Mars Reconnaissance orbiter, orbiting the Mars now, sent by America in 2006. So this is about the width is about 6 kilometers. The height is also about 6 kilometers. So small part of it. So I repeat, Perseverance rover is here, a bit or not bad, descent stage, parachute and back shell and heat. Now I just want to tell you, remember when it happens that the 7 minutes of terror, so when the rover is at about 11 kilometers from the Martian surface, the parachute will deploy. And when the parachute will deploy, what happens is the heat shield will fall off. So you see, the heat shield is on the top right hand side. Hey, funny, how come? I was very funny. By right, the heat shield should be on the left. But I explain later, it can be explained. heat shield is here on the right, and then the rover landed here. And of course, the heat shield will fall off first, and then later on, the back shell will be pulled off by the parachute, and then the descent stage will carry the rover, and you have this retro rocket will fire onto the Martian surface, and then the cable will release, and then this what they call rover will be held by the cable, and the moment the rover touch the surface of Mars.
Sorry, Dr. Chong, sorry to interrupt. Can you hear me?
Can you hear me?
Yeah, sorry to interrupt. I think there's some problem with the Facebook site, so I may need to restart the stream on the Facebook, but the YouTube one is okay. So just a quick, the audience, if you are, you may want to switch to YouTube now. So I'll try to restart the live on the Facebook.
Yeah, so
in a few minutes times. Yeah, please check back in.
That means I start right from the beginning.
Or maybe you wait for me for a few minutes.
I know, but do I start from the beginning, from the zero?
I think so, because the Facebook one is just sound totally lag, it's totally cannot load.
Okay.
Yeah, so, it's just about 1 to 2 minutes. I'll let you know. Yeah.
Okay. Sorry, guys. Sure. So never mind. We can chat again, live.
Yeah.
Chat again.
Yeah.
Sorry about that.
So never mind. Thank you, Michael. You're most important. You're the director. Yeah. Without you, nothing can go.
I quickly restart the live on the Facebook.
So live, we have to introduce again, Michael?
No need let me see how.
Now I try to stop also, it stuck a bit. Yeah, I changed the setting.
Yeah. So both Marcus and Ryan, if you people are good, confident, if you enjoy it, you can present more in future. All right, And Ryan, anything about aerospace, you can ask Mr. Lai Hong Jun. He's doing his PhD in aerospace engineering in Beihang University in Beijing, the top aerospace university in China, and one of the best in the world. All right, Lai is there for more than a year already.
So,
wait,
to our audience in Facebook, Facebook Live still continue or?
Oh no, Facebook stopped already, but the YouTube continue.
YouTube continue lah. Okay. So for our audience in YouTube channel, so just in case if you have any questions, feel free to type in the comment section on the left side, on the chat box on the left side of, sorry, on the right side of the YouTube session. Then we will try to answer you. We will try our best to answer you all the questions. All right. So do we welcome all questions?
Yeah. Continue now.
Wait.
Not yet. So while waiting for our Michael to solve the technical issue on the Facebook side, all right. So just to remind our audience to, if you have any questions, okay, just type it in the comment section and we see it. We will reply you. We will try our best to give you the best answer we can provide.
Yeah.
All right. We have Dr. Chong, we have Ryan, and we have Marcus over here. They are expert in astronomy. Or even aerospace field, so they can give you. They will try their best to give you.
Okay, I think we can continue. Sorry, yeah.
Okay, continue. I continue. Thank you, Michael. Okay. So now again we go back to, as I said, today is 27th of February. Perseverance landing site for Mars Reconnaissance orbiter. So again, I'll repeat here again. So this is a picture of the Martian surface taken by the Mars Reconnaissance orbiter, American rocket that is orbiting around Mars launched since 2006. So on this picture, which is about 6 kilometers by 5 kilometers, and then you see these two craters. Each crater here is about 500 meters, and here the Perseverance is here landed now. On the right side is the heat shield. All right, and then here is the descent stage and the parachute shell. So the moment I said, how come the heat shield on the right? I can explain. Now I'll show you detail. So today is on the 27. All right. Today is Sol number 8. So they use the word Sol is the Latin word for sun. I mean, this is one Martian day on Mars, so it's Sol 1. Of course, this is for Mars. Let's say in future you land a rover on Venus. So on Venus also can have Sol 1 and Sol 2. Sol 1 means for Venus. But this is the eighth solar day already. The rover has landed. Remember, landed on Malaysian time, Friday, February the 19th. So now it's 27. So actually the 8th solar day that the rover has landed. All right. And then of course some will say, wow, although actually sorry guys, for the first 10 days, they are just checking all the equipment on the rover and on the Ingenuity. No movement yet. The rover is stationary. It won't move. Maybe after the 10 days, you start moving a bit. So maybe after the first 1 or 2 months, then only you start moving. All right. So for example, this is where it landed. All right. You saw that. It's about 6 kilometers by 5 kilometers. Here is the Perseverance rover. Here is the heat shield. Here descent stage, parachute. Okay. And now this is of course the Mars Reconnaissance orbiter orbiting around in the space around Mars. So the rover Perseverance will send the radio wave to this orbiter orbiting Mars, and this will relay with a high bandwidth back to our deep space network of NASA. All right, remember 3 big radio telescope in California, USA, in Madrid, in Spain, in Canberra, in Australia. So anytime they can receive signal from Mars. All right. So now this again, look at this. This is the near the part where I landed. The what do you call this? Green thing is where I landed. Of course, the Jezero crater is much bigger. So this small ellipse is about 8 kilometers in diameter. Of course, this big one is the Jezero. So I repeated, recently we talked about the landing. Jezero crater is about 45 kilometers in diameter. The whole of Penang Island can go inside Jezero. Or the whole of Kuala Lumpur city can go inside Jezero. But here is a small part. So this is about 8 kilometers. So this is a small part. So this could say Georgetown can go inside. Okay. So this and last person. So this where landed. We have these 2 craters. And here is the part. The northwest part is where this dry river delta is, where the rover is going to do extensive research over there later. All right. So this is it. And this is it. Okay. Bigger. And there you are. Okay. So from here to here is about 2 kilometers. All right. 2 kilometers southeast from the river delta where it landed. And this is another picture where the red part is the elevated part. Small. This is not a hill, elevated part. So they choose the part that is green. So it landed. It will be easier. So if you look at it, it cannot go directly left, To the left, a lot of slightly elevated. So you may have to travel through all the green channel like a maze. Finally, it will go to the top left. All right, the Dry River Delta. So we look at it here. So when I first saw this thing, I said, how come? How come the heat shield is on the right? It's like that. Remember, okay, this is the Perseverance rover and Rush. This is the parachute back shell, descent stage. This is the heat shield. They say, how come the heat shield is on the right? All right, how the heat shield? I was thinking, then I look at it, I understand. Remember, it landed actually in this Syrtis major region. Remember, when the Perseverance rover with the what we call the entering the Martian atmosphere is always coming from the left to the right, from the west to the east. Just like on the Earth, most of the rockets you go and send into space, when they come back into Earth's atmosphere, it's always enter from the west to the east, not exactly west to east. It can be from the south, from the southwest to the northeast, or the northwest to the southeast, but generally from the western direction towards the eastern direction. So now it enter from the west to the east. So how? So how can it be? Oh, then it can be understood. Remember when the heat shield was dropped? That time the whole system was about 11 kilometers from the Martian surface. So the parachute opened at 11 kilometers from the Martian surface, and the heat shield dropped off. And at that moment, the heat shield is entering the Martian atmosphere at about 300 kilometers per hour. So in other words, from the west to the east, So in other words, when the Perseverance rover and the descent stage and the parachute is coming down, the heat shield is still going towards the east at 300 kilometers per hour. But of course, the parachute will slow down the Perseverance. So suddenly, that means the heat shield overtook them and hit the Martian surface on the east, not east. All right. Then later on, the parachute will be released earlier, so that the descent stage that is dropping the Perseverance on the Martian surface, it will drop the moment the Perseverance 6 wheels touch the surface. The descent stage will cut off the cable holding the rover, and the descent stage will follow. So then we know that the parachute will drop the person earlier. That's why the parachute is on the left. Now I ask myself, why must the descent stage towards the northwest? Why not in the east or towards the north? I was thinking maybe like that, because you see, the whole rover, the parachute was actually entering the Earth, the Martian atmosphere from the west towards the east. So that means this person rover was actually going slowly from the left to the right, west to the east. So that means hopefully if the descent stage were to drop the person and fly away, it's better for it to go to the west part of the perseverance. Hopefully, if the perseverance is going towards the right, the descent stage may fall onto the right, so not nice. So that's why descent stage must be on the left. So that's it. All right. So now you see that's how it is. So very exciting. I'll go back to the picture again. Very exciting. We see all these pictures. And now the thing is, now ladies and gentlemen, be patient. This is soul number 8. According to what we know, the first 10 days, the rover is not going to do anything. Ingenuity, not yet. So slowly after the 10 days, maybe slowly they'll start moving one camera low, do a bit of activity. Maybe only after the 10 days, you start moving slowly. You cannot move very fast. Slowly, to have full functioning, it will take many months. Right? And we know that once they find somewhere here, an area which is flat, the size of a football field. All right. Remember, this square is 200 meter by 200 meter square. We'll find a square which is 400 meter, which is 100 meter by 100 meter, a football size area, flat area. Then only they will release the Ingenuity helicopter, and the Ingenuity helicopter has a planned mission of flying 5 times. If you can fly more times, better. Flying 5 times. So that means now still no movement yet. We wait for excitement to come. All right. So now we go to the next picture. Lai, you can continue for the next picture.
Yes.
Okay, I'll check out.
Right, so I will share my screen first. So next we will proceed. All right, so once again, good evening to everyone, ladies and gentlemen. So now let's proceed to the APOD on 25th of February, which is 2 days ago. All right, so this is actually a flyby images sent back by a Venus flyby images, okay, sent back by this mission called the Parker Solar Probes by NASA. All right, so Parker Solar Probes. So from this, from this photo over here, we have this the Venus. We have the Venus, and then of course this picture is taken by this Parker Solar Probes. All right, and in this photo we see Venus, the largest terrain. All right, the largest highland in this Venus, called the Aphrodite Terra. Okay, this dark spot is the Aphrodite Terra. Right, it's a highland. It's like our Genting Highland is a highland lah. All right. So a little bit information about this Parker Solar Probe. All right, is something looks like this. All right. So this is the top view, and this is the side view. Right. This is side view. This is the side view. This is the top view. So this Parker Solar Probe is actually it's launched on the year 2018, August 2018. All right, using the Delta 4 Heavy rocket from Cape Canaveral. So on this spacecraft, all right, this Parker Solar Probes, right? Of course, from the name we know is going to the sun, going to carry out some research, some study on the sun. So there are 5 missions, right? There are 5 missions. So over here there are 5 payload system. So they have this sweep, they have this sweep, all right. They have this ISIS, they have fields, and they have this WISPR. So for this field, right, FIELD is the short form for electromagnetic field investigation. All right, the function of this field is to measure electric and magnetic field, radio wave, and plasma density and electron temperature. Right, so this field Okay, there are two. One is over here and over here. So the payload is actually two systems, right? They have the antenna system for communication, and then they have magnetometers and plasma sensors over here, plasma voltage sensors over here. So all the sensors are over here. So these are the fields. And then this ISIS, this one is actually to measure the energetic electron, protons, and heavy ions. So it's for energetic particles measurement. So they have two, all right? One is called the EPI low, another one is the EPI high. All right, the EPI low is over here, the EPI high is somewhere over here actually. So both are actually like a 90 degrees, almost 90 degrees or slightly more than 90 degrees angle. So can actually measure the energetic particles from different sides. Okay, so there are two, and WISPR is the wide field image for solar probes. So this is the system, right, that capture this flyby image of this Venus, sorry. So it's actually an optical telescope, all right. It looks quite mini over here, all right, but it's actually very useful, all right. There's an imaging system and a telescope over there, optical telescope over there. So it's actually the main objective of this system is to capture image of corona and the inner heliosphere. Of course, during this flyby also, it will capture the image of this Venus. So it's like a additional work, extra bonus for us on Earth. And then for this sweep is solar wind electrons, alphas, and protons. So it's actually used to count the electrons and protons and helium ions, and also measure the properties. Okay, measure their properties. For example, they measure the velocity, the density, and the temperature. All right. So this sweep also, there are two parts. Okay, one is in front. All right. Even though they are the same system, but they are not put together. All right, they are at different places. So this sweep span A is over here, and another one is SPC. SPC stands for Solar Probe Card. Okay, it's the one in front. Is this mini thing? Not the whole big thing. All right, the whole big thing actually, there's a big cover here, is the thermal protection system, because this spacecraft is going to the sun. So we know the temperature is extremely high. So this thermal protection system is extremely important, because without this thermal protection system, all right, all the device here, or most of the device here, will overheat. So we know all, especially electronic devices, sensors, we have this optimum, or we have this ideal operating temperature, ideal operating condition. So in the space, especially nearer to the sun, the temperature is extreme. So this thermal protection system is important to make sure all these sensors, or all these devices, electronic devices can work well, all right, or at least it still can operate when it nears the sun, which is reach the target lah. And also these solar array wings, there are two solar array wings, all right. It's actually the solar panel. Since we are going to the sun and we have this solar energy, so of course we should make use of this solar energy instead of using other source of power system. So this is the solar array wing. So when it nears to the sun, it's actually will deploy, right? Will open up. So it's like a mini wing. All right. So this spacecraft over here, all right, this Parker Solar Probe, okay, will actually do 7 flyby. All right. This mission is actually designed for 7 years, counting from 2018. So it's expected to end at 2025. So now it's 2021. So it has been launched for about 2 years plus, almost 3 years. And sorry. And they have completed up to today, all right? They have completed 4 flyby, all right? 4 flyby. The 4th flyby is quite recent. It's actually 1 week ago, on the 20th of February. And this image over here is actually captured during the 3rd flyby, right? The 3rd flyby is on July 11 on 2020. That means last year. So this image is actually captured half year ago, and then only today they release it. All right. And of course, the other 3 flyby, the next one will be on this year, 16th of October. And the other 2, the last 2 will be on 2023 and 2023 and 2024, which is another 2 years or 2 to 3 years time. All right. So this is about this system. So for flyby, there's something very important is the escape velocity. So we know the Venus is almost the size of the Earth, all right, more or less the size of the Earth, slightly smaller. So the escape velocity is almost quite similar to Earth, right? The escape velocity for Earth is 11.2 kilometer per second. For Venus is 10.36 kilometer per second. So don't worry, during this flyby, the spacecraft will not be captured by the gravitational of Venus, all right? But this flyby is important. Why we need to perform this flyby is because we make use of the gravity of Venus to help us to change, all right, to alter the orbit of this spacecraft. So this flyby is important. So all these 7 flyby is designed to make use of the gravity of Venus to alter or to slightly change the orbit of these Parker solar probes. All right, so that we can save a lot of energy instead of we perform the maneuver by thrusters or we have this power system. So this is about the APOD on 25th of February. And next we have the next one is on the 24th of February. We have this Messier object, or Messier object 66. We have this, it's a spiral galaxy, right? M66. So this image is actually taken from Hubble Space Telescope, all right? And then we have the raw image from Hubble and then processed by Leo Schatz, all right? Leo Schatz process this image and we have what we see now. So this object is actually discovered by this Charles Messier in the 18th century, 19th centuries. And this is actually located in this constellation Leo, all right? So together with M66, M65, and also we have another one we call the NGC, New General Catalog. New General Catalog 2, if I'm not, yeah, 3628, NGC, New General Catalog 3628 with M65 and this one, M66, it forms the Leo triplets, or the Leo trio. Right? It's a group of galaxies in the constellation of Leo. And it is visible during spring, so now is the best time for you to visible. The best time is around now you can see Leo. And also the best time is actually in April, 9 p.m. you can see Leo right up in the sky. So this is called an intermediate spiral galaxy. Why we call it an intermediate spiral galaxy is actually classified, it's not a bar spiral galaxy, all right, but it's also not a fully spiral galaxy. So you look over here on the center of this M66, all right, it slightly looks like a bar, but it's not actually a bar. So they classified it as intermediate spiral galaxy. It's intermediate, it's between spiral and bar spiral. All right, and from this image you can also actually see, all right, based on the caption below, all right, the objective of this image taken is actually for studying the formation of stars, the relationship of formation of stars, and also the interstellar clouds. So they found that, all right, it's not actually they found that, all right, they haven't have any conclusion, but they hypothesized that on this pink region is actually hydrogen clouds, all right, and this blue region is actually newborn stars. So at these regions, star formations are more active, right? Star formation is more active. So a little bit more information is about, this is Leo, the constellation of Leo. So M65, M66 is over here, all right, and the New General Catalog 3628 is slightly above, all right. And also it says M65 and M66 is one full moon angular distance. All right, it doesn't mean that M65 and M66 is very near, a few thousand kilometers. It's actually the distance for M65 and M66. We look over here, it's like very near. It's like close together, but the distance is actually 200,000 light years. All right, from here to here is 200,000 light years, and they are actually about 30 million light years away from Earth. 30 million light years, if I'm not mistaken. Yeah, 30 million light years away from Earth. So this is it about the APOD on 24th of February. So next I'll pass to Ryan to continue with the session. So
okay, let me share my screen. Can you see?
yes.
Okay. Not yet, Ryan. Not yet. Put your screen. Go to the next window and you have the picture. Yes, now
yes,
we see.
We can see your screen.
Okay.
So I'm going to start by presenting the APOD for February the 22nd. This is the picture. It's been named Moon Rising Between Starships. Now, this photograph was taken at Boca Chica in Texas, and it was taken by a 20-year-old spaceflight photographer named John Cross. You can see his name right over here. Now, this photograph really has two main parts. The first part are these two things right here. These two spaceships. They were built by a company named SpaceX. And SpaceX just last year became the first private company to send humans to the ISS. Now, what SpaceX has been working on recently is something called the Starship. The Starship. And that is what you see in the photograph. Now, Starship is supposed to be a two-stage, fully reusable spacecraft that can go from bringing cargo into orbit around the Earth, all the way to sending humans to the moon, Mars, and beyond. But before we can do that, we need to test it. So what you see here, these two are actually the test spacecrafts. This one has been named SN10, and this one SN9. Now the SN stands for serial number. That's the serial number of these spaceships. Now, a bit of a backstory. Before these two tests, there was another test done called SN8. And in that test, what was supposed to happen is that the rocket went straight into the sky, reached heights of about 10, 12 kilometers, and then it would maneuver and return to Earth in a horizontal manner. So it would be belly down, returning to Earth, and just as it's about to land, it would use thrusters to place it back vertical and touch down. With SN8, there was low pressure, and that caused the entire rocket to hit the ground too hard, causing it to explode. Something very similar happened with SN9. With SN9, one engine failed to fire, and the whole thing blew up. But now SpaceX, they think that they know what the issue is, and they said that they've fixed it on SN10, so we'll wait to see what happens with SN10. Now, the other part to this photograph is the moon here. Now, this moon, yes, it is a full moon. In other words, we can see the entire moon. The entire moon is fully illuminated. But at the same time, because of when this photograph was taken, which was in the month of January, it is not only called a full moon, but a wolf moon. Now, the reason that there is an actual name to the moon because it's in January is because you see moon cycles, a full moon cycle from new moon to full moon back to new moon takes about 29.5 days. And because of that, if you were to add up about 12 cycles, you get 354 days, just 11 days short of the full 365, which means that in general, every month there should be a full moon. Now, sometimes every 2 to 3 years, yes, there is a second full moon in that month. Those we call blue moons. But in this case, in this year, we only have a single full moon per per each. In this case, the full moon of January has been named the wolf moon, and the reason it's called wolf moon is because it's commonly associated with the belief that the Native Americans called it wolf moon due to the howlings of the wolves during that period. And why were the wolves howling? They were hungry. This was in the month of January. So that's really what there is to this photograph. You've got SN10, SN9, and then you've got this beautiful wolf moon looking as if it's rising from between the two starships. Okay. Now, the second photograph that I will be discussing is of February 21st. And its name is NGC 2244, a star cluster in the Rosette Nebula. Now, let me go to this photograph. This photograph was taken by a man named Don Goldman. And he's also referred to as Astrodon. Now, you see what makes Astrodon very special is because he is the developer of Astrodon filters that are used in astrophotography. So the man behind these filters used on cameras is Don Goldman, Astrodon. So this photograph was taken, and although it's the APOD of February 21st, it was actually taken in January of 2014 at the Siding Spring Observatory in Coonabarabran, Australia. And now what this photograph depicts is something called NGC 2244. Now 2244 is just its number. It's a 2244th, and something called the NGC. Now the NGC is the New General Catalogue for Nebulae and Star Clusters. So this is the 2244th in that catalog. Now, NGC 2244, also known as Caldwell 50, because it's part of the Caldwell catalog by Sir Patrick Moore, it is inside a nebula called the Rosette Nebula. Now, the Rosette Nebula, it's much bigger than this, and the Rosette Nebula is sometimes referred to as the skull. Now, it's partially visible from here. The reason it's called that is because this area right here that we're looking at, this is supposed to represent the left eye of the skull. This area towards this side is the right eye, and you can see some parts of the nose right here. But because this is more focused on NGC 2244, you can't exactly see the whole thing. Now, the Rosette Nebula is inside a constellation called Monoceros, the unicorn constellation, which is right in the center of Gemini, Hydra, Orion, and Canis Major. Now, NGC 2244, the brightest star in terms of apparent brightness. Now, in terms of apparent brightness, is a star called HD 46223, which we can see right here. This is HD 46223. Now, the HD, that stands for the Henry Draper catalog, which it is a part of. So now, as HD 46223, the star itself is about 38 times brighter than the sun, but in terms of its temperature on the surface, it's a little over 4 times hotter than the sun on its surface. Now, yes, I did say that HD 46223 is the brightest star in terms of apparent brightness, which means that it's not in terms of the actual brightness of the star itself. If we were to talk about its actual brightness, it would have to be this star right here. Its name is 12 Monocerotis. Monocerotis. This star is 155 times brighter than the sun. Now, at the same time, these two stars, they are different types of stars. 12 Monocerotis is called a K-type star, and HD 46223 is an O-type. Now, these classifications using K and O, they come from a classification called they come from a classification where the order of the letters, which goes O, B, A, F, G, K, M. In that order, M is usually referred to as the least as the coolest of all the stars, while the O's are the hottest. And as you could see just there with this O-type star, it was 4 times hotter than the sun. Now, the other stars that you can see here, a lot of them are O-type stars because NGC 2244 is largely populated by O-type stars, which emit mostly in the ultraviolet spectrum. Now, the other stars you can see include this one right here, HD 46150. Then you've got this one right. Wait, let me make sure I've got the right one. This is HD 46149. So this is 46149. This one right here, that is HD 46106. And this star right here, this is HD 46056. So all of these HD 46s, they are all they're all O-type stars. It's only this one right here, the 12 Monocerotis, that is a K-type. Now, at the same time, let me zoom out a little in this photograph. There are actually specific colors to each of the different elements. Sulfur, you can see as the parts shaded red. Hydrogen are the parts shaded green, and oxygen are actually the parts that you see shaded blue. So this is NGC 2244. Now, the next photograph is February 20th, and its name is Perseverance: How to Land on Mars. Now, this is one of the things that was mentioned earlier in this session. A lot of the photographs here are on aerospace and on space travel, and one of these right here is one of those photographs. This is a picture of the Perseverance rover. Now, if we look at the image credit, it says NASA JPL Mars 2020. That's because it's part of the Mars 2020 mission, and it was by NASA. But this photograph, the engineers behind it work at JPL, the Jet Propulsion Laboratory, which is under NASA. So let's go to that photograph. Now, first, I want to talk about what is going on here. What is going on is that what you see here, this is the Martian surface. And you can see a lot of wind right here. This is actually wind on the surface. And then you've got the Perseverance rover, which is being carried by the descent stage. The descent stage was covered in the first photograph. And the descent stage acts as a little jetpack. You see, once Perseverance, the rover, enters the atmosphere, and after its parachute comes off, the heat shield is off, NASA uses a jetpack, an actual jetpack which has 8 thrusters to hover this rover just about 20 meters in the air, and then use these cables right here. These cables carry it down in what's called the sky crane maneuver. Now, one of the things here that is not exactly a cable is this one. This is not a cable. This is the umbilical cord. At least it's not in a cable whose purpose is mainly to carry it. The umbilical cord transfers information between Perseverance and the descent stage. Now, when it comes to something like this, they have to make sure that everything works very well. Because what you're looking at right here, Perseverance, this entire project of Mars 2020, its building time took about 11 years from the part of thinking about it. Curiosity, which was the rover right before this, only took 7 years. And Burj Khalifa, for example, the tallest building in the world, took 6 years. Now, in terms of money, This rover used this rover. Its total cost was about $2.4 billion. The rover before this, Curiosity, took only about 2.5 billion, but that was, took 2.5 billion, but that was because Perseverance is able to take some parts from Curiosity. They did not need to rebuild the whole thing. Now, Perseverance, it's also the first rover to use what is called terrain relative navigation. Terrain relative navigation is a software used where the rover, which has cameras on its bottom, as it enters the atmosphere, after it has gone through the entry and it's finding a place to land, it uses those cameras, takes pictures, and compares it with an onboard map. And it uses that to find the perfect place to land and touch down. At the same time, Perseverance is also the first rover to have the names of people all around the world. NASA started something where you can actually sign up, you fill in your name, and you get a boarding pass. Now, this boarding pass will have your name, has a picture of Perseverance, and the purpose of that photograph, of that boarding pass, it's sort of a certificate, because all those who signed up have their names on 3 silicon chips that are on a plaque on Perseverance itself. So yes, you've got about 10, it's close to 11 million names that are on Perseverance. Now, there are a few things that we can see from here of Perseverance itself. For example, we can see these wheels. The wheels have been deployed. Then you've got the super cam, which is sort of the head camera, the main circular camera that you see on its head. You also have parts of the drill that can be seen here. And one thing that I want for all of you to remember is this piece right here. These are called HAZ cams, and we'll be talking about HAZ cams in the next photograph. So moving on to the next photograph.
Wait a minute.
Yes.
Allow me to add on.
Mm-hmm.
So we know that the gravity of Mars is only 30% that of the planet Earth. So on the planet Earth, the rover person weighs 1 ton. Therefore, right now, it's hanging on the surface of Mars. Its weight is only 380 kilograms only, the rover. All right?
Yes, that is true. This entire Perseverance rover has the weight of a car and is actually car size to a certain degree. The dimensions of the rover, it's actually 2.9 meters in length, 2.2 meters in its height, and 2.7 meters in its diameter or in its width. Now, we'll talk more about Perseverance in the next photograph, where we actually cover the HAZ cam. So let's move on to the next photograph. So next photograph here is 2021, February 19. Mars Perseverance Sol 0. Now, as Dr. Chong mentioned previously, Perseverance is now on Sol 8. This photograph was taken on Sol 0. It was taken when it touched down. It is actually the first photograph to be taken by Perseverance. Now, when it comes to data transfer, Perseverance itself can send confirmations of touchdown. It can send information that the cables have been released and things of that sort. But when it comes to photographs, because photographs, they contain a lot of data. They are not just, they are not things such as touchdown confirmed. They are more than that. So what they have to do is that Perseverance actually sends this to an orbiter called the Mars Reconnaissance Orbiter, or MRO. So the MRO, the Mars Reconnaissance Orbiter, would then take that image and it would send it back to Earth. So that's what this image here is. Now, as I mentioned just now, there was that HAZ cam. These HAZ cams are placed on the front and the back of all of the most recent, of all of the last 4 rovers to touch down on Mars. There have been a total of 5 rovers that successfully landed on Mars. The first was Sojourner in the 1970s. Then there was Spirit and Opportunity, the twin rovers in 2004. Then closer to 2012, 2013 was the Curiosity. So around 2011, 2012 was Curiosity. And then most recently, Perseverance in 2020. Landed, of course, in 2021. Now, you can actually see the shadow of Perseverance here. So this is Perseverance itself. Now, the reason this looks warped, it's not because when Perseverance is standing there, or if you were to stand there, you would actually see it warped. No, Mars is not that small. This is because they used a fisheye lens. So in certain times when NASA wants to release more photographs, they do process it sometimes so that you don't see that fisheye curve. Now, to talk more about Perseverance, its purpose is to search for life on Mars, is to see whether there is any ancient microbial life on the planet of Mars. Now, at the same time, it also has certain things to help future human missions. One of those things is something called MEDA. Now, MEDA stands for the Mars Environment Dynamics Analyzer. And what it does is basically measure the weather and try to predict the weather, because weather is not something you want to mess around with on Mars. Weather will play a very important role in later human missions, so we have to make sure that we get those accurate. At the same time, there is another device called MOXIE. Now, this is a very famous device that was placed on Perseverance, and it stands for the Mars Oxygen ISRU equipment. Now, ISRU, it stands for In Situ Resource Utilization, which is basically to use the resources that you have in that area for a certain purpose. Now, in this case, the resource that they're using is carbon dioxide. Carbon dioxide fills up about 90+% of the Martian air. That's why we can't breathe there. But what MOXIE is going to try to do is basically to turn that carbon dioxide into oxygen, similar to what a tree does. It's basically turning this carbon dioxide into oxygen. And that oxygen can be used for many different purposes. Something that not many people actually realize is that oxygen and water, actually, not only oxygen, but in this case, more specifically oxygen, it has a few purposes. For one, yes, it's something that we can breathe. Now, at the same time, when it's with hydrogen, it's something that you can drink, H2O, water. But at the same time, it's used in rocket fuel. You have your fuel and you have your oxidizer. That is the oxygen. So having oxygen on a planet such as Mars, which doesn't have that strong of a gravity, will be very useful in future human missions. Now, what else is there to say about Perseverance? Well, it's carrying along with it a partner, a technological demonstration called Ingenuity. Now, Ingenuity is a technological demonstration of the first powered air flight on Mars. Not the first air flight, but the first powered air flight, because there were flights done by the Russians using in Vega 1 and Vega 2, where they tried out a balloon. So it's not exactly the first flight or air flight, but the first powered flight, because Ingenuity is a drone. It's a helicopter. And this helicopter, it's very light. It has 4 legs and two counter rotating propellers. Now, on a normal helicopter, you would have 2 propellers. You would have the topmost propeller, which connects to the body, and then you have a propeller right in the back. There's a propeller right here. Now, the reason is, if you only have this one propeller, with only one propeller, the helicopter itself will be spinning around. you need something to counteract that. And to do that, most helicopters use this second propeller. Now, what Ingenuity does is that it actually has the second helicopter, it has the second propeller on top, right here. So one will be rotating clockwise, one will be rotating clockwise, the other one will be rotating anti-clockwise. So that way it balances the helicopter itself. So Perseverance itself has been packed with a lot of other things. Now, as I said just now, its purpose is to search for life on Mars. So one of the things it has is a drill section. It's a robotic arm, and right at the end is a drill that will actually drill out a chalk piece of Martian soil, and it'll encapsulate it and keep it in its underbelly. So it actually has two robotic arms on it. It's got the one that you usually see, which is the one that moves out, that drills things. But at the same time, it's got one in the underside that would take whatever samples from the drill and slot it into different holes on the bottom for storage. Now, at specific points, Perseverance will be dropping these samples, and it is planned that future Mars missions, perhaps in 2031, will go there, pick up the samples, return them to Earth, and run tests that we just can't fit on a rover. Now, besides that, Perseverance, one thing that I didn't mention, Perseverance and Ingenuity, just like Curiosity, got their names from schoolgoers. So NASA held a nationwide competition where different students would have to send in a name for the rover or the helicopter and the reason why they want it to be named that. So the names that were chosen were Perseverance and Ingenuity. Now, to end this photograph, I'd like to mention that this single photograph, it was sort of the sole reason that millions of people stayed and watched the NASA and watched the landing happen in real time. You see, in Malaysia, because of the time zones and the time difference, the landing happened at about 4:55, 5 a.m. Malaysian time on the 19th of February. So at least 40,000 Malaysians, those that sent their names to be on the rover, stayed up and watched this happen, including us. And it was all really for this photograph, this one black and white photograph. Now, yes, one thing that I did not mention was the fact that it is black and white. And the reason it's black and white is for faster transmission and to have better resolution. Now, yes, I do say better resolution, but it might seem to be a little bit blurry. That is because there's still a protective cover on it to protect it during the re-entry. Now, I may not have mentioned it previously. I did mention the cost of Curiosity and Perseverance, but just as a comparison. As I said, Curiosity was about 2.5 billion, Perseverance was 2.4 billion. The Burj Khalifa, for example, the tallest building in the world, was about $1.5 billion. So these rovers that we sent to Mars were more expensive than that. And there is a purpose to it, because all missions that we send to Mars, they are really to better our position on Earth. A question often asked is why do we go to space when we've got so many problems on Earth? It's to help. It really is to help the problems on Earth, because when we innovate and we create new technology and we learn new things in space and beyond, in Mars and beyond, those things end up helping us back on Earth. So I believe that's all for my 4 photographs.
Thank you, Ryan. All right. So we continue. So the next one is for February the 18th, which I see here, Swiss Alps Martian Square. Okay, huh? Can you all see my screen, Ryan? Can you see, Marcus? Yes or no?
Yes. Yes.
Okay. So February the 18th, Swiss Alps Martian sky. There you go. Okay, I'll make the picture smaller. Okay, Swiss Alps Martian sky. So it's taken by a Swiss astrophotographer. It looks interesting. Desert? No, ladies and gentlemen. This is the snow mountain in Switzerland. The snow. So this is the snow. The somewhere in central Switzerland. There's a mountain, and these are the rocks poking out. And this is the white snow, and this is the sky. How come the white snow is like chocolate color, red color? That's the reason, because we know that from time to time there's a kind of a Sahara Desert sandstorm. Remember, Switzerland is north of the Mediterranean Sea, right? And south of the Mediterranean Sea is the Sahara Desert, which is what? Algeria, Tunisia, Morocco, Egypt, Libya. So you can have big sandstorm, and it will blow all the dust. We fly up into the higher atmosphere and blow northwards and fall not only on Switzerland, on Europe. So in this case, there's a sandstorm in Sahara, and the dust was blown northwards over the Mediterranean Sea, and then it even settled down onto the white snow there. So basically, the snow here got this chocolate color or red color because of the dust from Sahara Desert, and also the sky. Why does the sky look a bit like brownish, reddish? Because this is the scattering of light by the dust particle. Right? Remember, on Earth, during a clear day, you have the white sun and the blue sky. All right. But here, because of the dust, you see a reddish sky. So that's why it says here, something here, that this looks like the Martian atmosphere. So if you're on Mars, this is how it looks like it. Remember, we said that the Martian atmosphere is just the look of the opposite that of the Earth. Remember, on the Earth, during daytime, when there's no cloud, you look at the sky, no cloud, the sky is blue for the Earth. And during sunset, let's say on the western part, you look at the western sky, the western sky is red for the Earth. But on Mars, it's just the opposite. So on Mars, you look up, vertically up, you see the sun. Every time in Mars during daytime, the sky looks red. And sunset, you look at the western part of the sky in Mars, sunset, the sky looks blue. Just opposite for the. So now it looks like what happens on Mars has come to the Earth because of the dust storm blown from the Sahara Desert into Switzerland. It fell onto the snow here and also in the sky. So daytime looks red. That's interesting. And you look carefully here, the sun looks a bit bluish, right? So interesting. So this is a Martian landscape, all right? Daytime, the sky looks red, and when the sun set or the sun rise at the horizon, the sun looks blue. So that's very interesting. Taken by an astrophotographer from Switzerland, all right? This is taken on February the 6th, all right? So the next one we continue will be February the 11th. I enlarge it first so everyone can see clearly. February the 11th here, which is Cygnus Mosaic 2010-2020. All right, there you are. I make it smaller. Okay. Which is for our February 11th. So this is taken over a 10-year period by this crazy guy, J.P. Metsävainio. So he's a Finnish astrophotographer. So Finnish what? From Finland. All right, Scandinavia. Remember, Finland is somewhere in the center. To the left is Sweden. Further to the left is our Norway. Further to the east of Finland is Russia. So this is from Finland. This guy, he took the picture over 10 years. He took it. Now remember, previously for the airport pictures, they were all the people who contribute will have to indicate in their picture what telescope they took, what camera they took, what is the processing image, and so on. Nowadays, our doctor, the two guys, Dr. Robert Nemirov and Jerry Bonnell, who maintain the airport site, they don't require to put this because they assume that the readers and the viewers of APOD are good enough in astronomy, they will know that this JP Mesabrino will use the correct thing. So that means this guy in Sweden has a telescope, has a good camera. He don't mention what telescope, what camera, but he's good in astrophotography. He will take this picture, right? So over a period of 10 years, constellation of Cygnus, right? So here also they say that this is somewhere in the plane of the Milky Way. It's called the Great Reef. So the Great Reef are dark regions in the Milky Way where the interstellar space is full of dust particles, which block the light from behind, right? So remember, whenever you look at a picture in space, not necessarily about the nebula, but more for a galaxy, right? So let's say I show you a picture of a galaxy now. There you are. Okay, this is our Leo triplet, the one that Lai explained just now. Just now, Lai was explaining one galaxy. Now you have a what I call a group of 3 galaxies, Leo triplet. Now, especially when you look at any picture with galaxy, you must know that basically 4% of the matter here is our atomic matter. 23% of the matter here is dark matter. Another 73% is the dark energy, right? But unfortunately, until today, the scientists have not identified exactly what is dark matter and what is dark energy. So when you look at the visible light galaxy, 3 galaxies like that, at the stars here, you know that this is only 4% of the universe. What do you mean by 4%? The atomic matter. What do you mean by atomic matter? The protons, the neutrons, right? The leptons, and so on, right? So basically, these are the 4% of the atomic matter. The 23% dark matter is there, but we still have not detected it. And the 73% dark energy. So basically, the whole universe, especially you look at a picture of galaxy, any picture of galaxy, you see that it will have 4% matter, 23% dark matter, and 73% dark energy, plus light. Light is also there, plus one more last thing, the neutrinos. So any picture of the universe will have five components: atomic matter, dark energy, light which is actually photons or electromagnetic wave, and finally neutrinos. All right, so this is it. All right, so let's go back to the picture just now about the Cygnus. Okay. So when you see here, of course, this is part of the Milky Way galaxy. So definitely here, you see a lot of atomic matter, but I think the nebulae or the space in the nebulae will not have dark matter. For example, in our solar system, in the Great Orion Nebula, I think they have not detected dark matter. But inside here, definitely there will be dark energy, because they say that dark energy is built into the fabric of space-time. That means in the room you're sitting now, in the city you are staying in now, there's dark energy in space, you know. Inside your head, inside your body also got dark energy, but you don't know what is dark energy. They say that, for example, that dark energy is, they call it the compactification of space-time. They say that what we know of 3 dimensions of space, 1 dimension of time is not all. The universe could have 10 dimensions or 11 dimensions. Let's say 10 dimensions. So 3 of space, 1 of time. Another 6 dimensions have been curled in, compactified, and into a small space that we cannot see. And the dark energy is in the compactification of space-time, right? So anything in the universe you see will have atomic matter, dark energy, light, and neutrinos, right? So this is for the Cygnus, all right? We go to the next picture. This is our February the 10th, all right? So the moment I saw this, I said, wow, what's this? All right, so you should know lah. So this is our VLT. What's the VLT? Very Large Telescope. Where? In Chile. All right, belongs to who? European Space Southern Observatory. Belonging to who? A group of European countries joined together, combined together the funding to build 4 large telescopes called the Very Large Telescope, and then they build it. This is one of them. So each Each telescope has a mirror of 8.2 meters in diameter. It's in Chile, and so this is done by our. See here, the name is the text is Juan Carlos Munoz. All right. So you see here that Juan Carlos Munoz is an astronomer, but he's also something like a coordinator of outreach activities in ISO. ISO is European Space Southern Observatory in Chile. All right, and this is of course in La Paranal. So any observatory must be put on the mountain, and the mountain's name is called La Paranal. All right, that means many years ago the European surveyed the mountain and flattened it by how? By blasting dynamite, blasting it until it's flat, and put the 4 big telescope there. So what they are doing here is what you see here. I make it smaller. The 4 lasers, right? And you can see here the large Magellanic Cloud, because this is in the southern hemisphere, and this is the small Magellanic Cloud, and this is the Milky Way. So they are actually doing adaptive optics. So I repeat, adaptive optics is nothing new, and it's very amazing. It's now done all over the world by most professional optical observatory, and even some amateur astronomers have it. So basically what happened is, somewhere imagine that this big telescope is going to image here, up there in space, a nebula, right? But the problem is, as the light from the nebula enters into the primary mirror of this telescope, it has to pass through about 100 kilometers of Earth's atmosphere, and that causes turbulence. So the picture that you see will be what you call not stable, right? Because of the air got turbulence. So basically, these 4 lasers will shine from the what you call this the observatory, go into space up to about 80 kilometers up from the Earth's surface, and will create artificial stars near to the nebula that they want to image. And this artificial star is created by energizing sodium atoms, Na. So in close to space, there are a lot of sodium atoms. So the laser will energize those sodium atoms, which will emit light. And when they emit light, this is an artificial star. So there are 4 artificial stars created around the nebula. So by observing the behavior of the 4 artificial stars, so when the light from the 4 artificial stars come down, so there's another small telescope will record what is the turbulence caused by the 4 artificial stars, and the information is fed back into the, remember, any telescope will have a primary mirror and a secondary mirror. So it's called the phase of the wavefront. Right? The wavefront means the light coming down from the sky to the telescope. We have a wavefront, and because the Earth's atmosphere turbulent, the wavefront is not flat, right, but disturbed. But after passing through the computer, it will make the secondary mirror counteract the disturbance in the wavefront. So finally, the final image that go into the imaging device is a flat wavefront. Flat wavefront, as if there's no disturbance. So that means they can cancel out the turbulence of the Earth atmosphere. So this is called our what? AO, adaptive optics. All right. Now remember, adaptive optics was tried by the American military in the 1970s, 1980s, especially what? The Star Wars program, Strategic Defense Initiative. But at the end of the program in the 1980s, it was declassified, and later on the astronomy community can enjoy. So now you can get very good picture by removing the disturbance of the Earth's atmosphere using adaptive optics. All right. So we continue. The next one is we pass over to Marcus. Marcus, for you.
Okay. I need to present.
Okay.
Okay, can you all see my screen?
Not yet. Can you switch to your next screen?
Okay.
Go to the next screen.
Can you see?
Now can see. That's the way.
Okay. So hi everyone. My name is Marcus, and I'm a member of the Astronomical Society of Penang, and today I'll be presenting the APOD for February 8, February 7, and February 6 of this year. So the first I'm going to be talking about is the February 8 APOD. This picture is titled WR23 and Interstellar Clouds in Carina. So in this picture, you can see there's two gas clouds. The one on the bottom left, it's called WR23, and it's caused by a wolf riot star, which is a type of star that is dying and is releasing all its outer layers and therefore causing this gas cloud. And the cloud on the top right is caused by a nearby small star cluster called the NGC3324 over here. And NG3C stands for the New General Catalog, like Ryan said. How did the star cluster cause this gas cloud over here? Well, stars all release winds and radiation, so grouped together they would be forming a gas. All the radiation and winds coming together would be forming a gas cloud. Alright, and now for the next APOD, which is I need to go back to the archive. Now for the next APOD, the February 7 APOD. This APOD picture is titled Blue Straggler Stars in Globular Cluster M53. So what is a globular cluster? A globular cluster is a star cluster that is in the shape of a globe. Most of the stars here in the M53 is much older and redder than our sun. And there is a hypothesis here that says that most, if not all, of the stars here were born around the same time. But there are a lot of stars here that looks much younger and bluer, and so it contradicts that hypothesis. And after much debate, the scientists came up with a theory that those stars were refueled by fresh matter falling from their binary companion, which means that the younger stars the stars that look younger should be binary stars. The M53 globular cluster has more than 250,000 stars and can be spotted near the constellation Cona Berenices, which is this constellation over here. You can see it's like a corner, and you can see M53 over here. And now for my last picture, it's titled A Northern Winter Night. So you can see this picture here. It's 360. So basically, it's instead of just taking a picture and uploading it to APOD, the guy who took the picture, Lucas Zach, which is a Polish astrophotographer, by the way, he took two panoramic pictures and combined them together using a photo editing software to form this 360-degree picture. So he took this in a town called Siemiony, Poland, which is in northeastern Poland, and it's near the border of a country called Belarus. In this picture, you can spot two constellations actually. One is called Aryuga the Charioteer, which is over here. You can see. Wait, let me find a good picture. Let me find a good. Here it is. Aryuga the Charioteer. And on the top right, you can spot the familiar stars of Orion. And near zenith, you can see the star Capella, which is the brightest star of the Aryuga constellation. It's a well-studied binary star system. And anyways, that's it for my APOD today.
Yeah. So Marcus, you let me go in. So we continue for the 4th of February, all right? Okay. Marcus, can you see 4th of February? Can
Yeah.
Okay. So for Apollo 14, remember Apollo 11, 12, 13 didn't land, 14, 15, 16, 17, all right? So 6 Apollo mission landed on the moon, and 12 Masale, 12 American men have walked on the moon. So basically this is what? Apollo 14, a view from the moon, all right? So that was in the 1960s and 1970s. And of course, this is by one of the NASA staff, Eric M. Jones, all right? And this is Edgar Mitchell, is one of the American astronauts. And you can see here, oh, wow. Of course, the flag here, of course, this is taken of the window of the lander, and the lander has a name, it's called Kitty Hawk. Kitty Hawk, all right? Now, Kitty Hawk is, although it's the name of the lander, but its original name is a kind of a beach in America, all right? Where the Wright brothers tested their first powered flight in 1903, right? Kitty Hawk Beach. But they named it this lander or like this. And what is interesting is, it seems that the Alan Shepard, one of the astronauts, was on the moon, play golf. He likes to play golf on the Earth, and he play golf on the moon, but you cannot see. So basically here, he hit the golf ball from near to the lander, and he flew very far here, and you can see this rock there. And according to them, they say that if you enlarge this picture big enough, you can see a white spot. The golf ball landed there. So I think this Alan Shepard played golf twice, on the moon there. All right. So there you are. You have this. Hey, what is this thing here? What is this? This is the nozzle of the ascent stage. Remember when the Apollo mission orbit around the moon, there's a command module. And in front of the command module is a lander and ascent stage. So the lander will land the 2 astronauts onto the moon surface. But the 3rd astronaut is in the orbiter, command module, orbiting the moon all the time. So only 2 of them land on the moon. So when they're on the moon, when they want to blast out the time, so this ascent stage will go out, and this ascent stage have to maneuver in space to dock with the command module, to go back to the Earth. So these are all the nozzles to reorientate the ascent module so that it can dock with the command module. So you see a lot of things here, very interesting, all right? Apollo 14. So if anyone you are keen, just to follow the 6th Apollo mission itself is so interesting. And then you see, what is it? Footstep, human footstep. You see so many steps they put on the moon. So if let's say they don't go back to this part of the moon, so this footstep will remain there for millions of years, except what? The micrometeorites. We know that, let's say if I enlarge this picture big enough, you find that every day, every second, a lot of tiny particles, charged particles, solar wind, and once in a while, a small particle of dust, all right, from space will hit onto the lunar surface. And the lunar surface also will be weathered, will be slowly eroded from the micrometeorites. But let's say on the moon, you have a big hole here. I don't think so the micrometeorite will change the shape of this hole, all right, on the surface. So basically, most of the footsteps caused by the American astronaut walking on the moon will remain there forever, right? Forever. So we go to the next picture. February the 3rd. Found on the moon, candidate for the oldest known moon rock. Well, it is a video actually. Okay, I'll just read first, all right. So basically, you have in NASA a laboratory for astromaterials, and it's run by a woman called Erika Blumenfeld and her team. So basically, in this laboratory, they collect a lot of materials from the moon and other parts of the solar system, and they study. So basically, on the Apollo 14 lunar mission, the previous picture, the same mission, they brought back a sample called lunar sample 14321. And what happened is, from this sample, they dated that sample as 4 billion years old. What does it mean? Remember, the oldest rock, this is the moon rock they brought back from the moon. But they say that the oldest rock that is found on the surface of the Earth that is not being processed, exposed, not being processed, is about 3.5 billion years old. All right, the oldest rock on the Earth's surface that is not being processed. But this moon rock they brought back from the moon, they found it that it is 4 billion years old. So how did they know? Radioactivity. So in all atoms in our body, everywhere in the world, the rocks, the wall you eat, the McDonald's, McChicken you ate just now, they are always radioactive isotopes. So by studying the radioactivity, they can date it. So that rock, which they brought back from the moon, they dated it as 4 billion years old. That's the oldest rock the date on the Earth on the surface unprocessed is 3.5 billion years old. So this rock that they brought back from the moon, and according to them, they have a lot of moon rocks brought back from the moon to the Earth. But they find that this rock is similar in characteristic to the Earth material. So the theory is that many years ago, a meteorite or asteroid hit the Earth and blew up the material from the Earth's surface, left the Earth's gravitational pull, and this material orbited in the solar system and later on fell back onto the moon. And when the Apollo 14 astronauts went to the moon, they collected the moon rock from the moon back to the Earth, but originally that moon rock came from the Earth. And that moon rock was older than any of the material found on the Earth, you know. So now I'll play the video. So basically, that laboratory in NASA, they take different sections of this what they call moon rock from the Earth, which is actually originally from the Earth, and this is the result. All right, it's a video. That's what we play. Okay, you see here, it looks like a liquid. No, they are taken from the bottom left-hand side, sections of it. They analyze this section from it, but they don't explain how they get the information. So they take sections of it, and they dated it as 4 billion years old, this moon rock. And this moon rock is very similar to the Earth's rock, and is even older than the oldest rock found on the Earth's surface. It's very great, you know. So we found that when you study something on one planet, you learn something about another planet. All right. So this is a classic example of what we call planetology. When you learn something about Mars, you know what happened to the Earth. You learn something about Earth, you know something about Venus. All right. So this is for our February the 3rd. Let's go to the next one. February the 2nd. All right. Now, this one actually in Penang, people were asking our ASP whether we are observing. All right. This is the first meteor shower of the year, quadrantid. All right. So it's taken by Frank Kusas. He's an American, what they call amateur astronomer from Missouri, USA. All right. So basically, the what they call the particle from space enter from the right and go to the left. And you see here, green, okay, a bit blue, white here, and here got red. All right. So basically, this guy, he must have put his camera, no need telescope, put his camera on a stand and exposed it for some time, and was lucky to catch a quadrantid. And this quadrantid meteor shower is in early January, the first meteor shower of the year, and it's surprisingly from an asteroid number 2003 EH1. There are only 2 meteor showers that is confirmed came from asteroid. One is this one, quadrantid, from asteroid E2003EH. The other one is our Gemini meteor shower. All right, Gemini meteor shower also come from another asteroid. But all the other meteor showers originate from comets. Okay, so basically this is it. And then from the different colors, indeed, it will tell us the different elements in the in it. And also you have this red thing. What is it? It's called the persistent train. We have seen in Penang before. For example, the Leonid meteor shower of 1998. You see a bright fireball in the sky, in the Earth's atmosphere, and then you can see this persistent train can last in the air for up to 20 minutes. Right? So this is called the persistent train. Of course, the tiny spots are the stars in the Milky Way. Right? Stars in the Milky Way. Right? So this is our quadrantid meteor shower by Frank Kusas from Missouri, USA. All right. We go to the last picture for February, which is the 1st of February. All right. This is very nice. 1st of February. And the title is 1st of February, Lunar Halo or Snowy Trees. Goran Strand is a astrophotographer from Sweden. Right. And so nice. I really like it. Why? You see the moon here and the lunar halo. You see the trees with snow in the tree. And then you see, and what is this? This is the, sorry, not human track, rabbit tracks. The rabbit also can take the cold temperature. So this is one set of rabbit tracks here, and another set of rabbit tracks. Right? You can ask Sherlock Holmes to analyze detective work. All right. So very nice. So basically, it's beauty on the Earth's surface and beauty in the Earth's atmosphere, and also beauty in space, the moon. All right. So basically, this is part of what's called atmospheric optics. So as the light from the star, from the moon, from the comet, and from the sun enters the Earth's atmosphere, you see very strange phenomena in space. So basically, this is caused by what? Millions, trillions, and trillions of tiny hexagonal crystals high up in the Earth's atmosphere, many kilometers, right? Earth atmosphere. So as the moonlight comes through from top below, enters the Earth atmosphere, and there must be no cloud, and it gets refracted, just like the light passing through a lens will split into the rainbow colors. So the light passing through the trillions of tiny hexagonal glass frozen crystal, you have refraction, and because of the symmetry of the problem, from here to here is 22 degrees, and from here to here 22 degrees, so it's 44 degrees, right? So this halo. But for the sun, we also see this phenomena. All right, if this is the sun, your solar halo, but because the sun is bright, you can see this is the first halo, 22 degrees. But for the sun, we have a bigger halo also. It's possible. For the moon, one halo lah. Don't be too greedy. For the one moon, 22-degree halo is good enough. So this is one, the lunar halo over the solar trees, over the snowy trees, all right, in winter in Sweden, all right? So nice, right? So I think that's about all for tonight, okay? So now we ask our Lai, Lai, any questions for us? Okay, I stop now. Any questions for us?
I have checked the Facebook and the YouTube channel. It seems like no question for us.
Yeah.
And
If don't
it
have, I
also seems
also.
like the time is quite. Oh, you have a question? All right.
I have a question for Ryan. Ryan, can you go back to February the 22nd, moon rising between starship.
Okay.
All right. Very interesting. I thought about this question just now. Moon rising between starship. So my question is, why did Elon Musk choose to test the Starship SN9 and 10 in Boca Chica in Texas? Why not he test it in Cape Kennedy? When most of his launches, the SpaceX, Falcon 9 Heavy, SpaceX, mostly taken from Cape Kennedy. Why he tested it in Texas? Why not in Cape Kennedy? Because most of the facilities are in Cape Kennedy. Big publicity. Why he tested it in Boca Chica? I don't have the full answer, but I'll make a guess. What do you think? Why in Boca Chica? Why not in Cape Kennedy?
Okay. We know for one that he plans to use Boca Chica as the actual launch pad for the Starships. But as to why Boca Chica?
But remember, I said already on the map, Boca Chica is just on the border north of Mexico. Just north of Mexico. And just to the east of Boca Chica, the Gulf of Mexico, the sea. You observed just now, there's a sea there, no? There's not a river, no? Just a sea. So why Boca Chica? Now, my guess is this. Starship SN9 and 10 technology is not well tested. Sure got accident one. He don't want to land, he don't want to test anything which is not tried and tested and damage and blast away all the facilities which are built for years and years in Cape Kennedy. In Cape Kennedy, remember, has been launched since the 1960s, you know. So if there's anything that damage, Elon Musk have to pay for it, you know. So he will only test something like our Falcon 9 Heavy and Minis, which are more or less tested before elsewhere. It works well. Then only he go to Cape Kennedy to test. He cannot test it. Anything he built new, he test in Cape Kennedy. Fail, damage, the gantry, the launch pad all damaged. So this is very, very unreliable technology. He cannot test simply first time in Cape Kennedy. But future flagship, of course, Cape Kennedy. Once you tested, why? Publicity. Maybe come to Cape Kennedy, all the beach there and all the hotel, Boca Chica, no hotel, nobody can see, Yeah, the Cape Kennedy, thousands and hundreds of thousands of people can see. Right now, still untested technology. Better don't try to launch it, test it in Cape Kennedy. That's what I think, lah. Huh?
Okay, actually, there's a question for us from the Facebook side. From Albert Thomas. He asks whether is it possible we can see stray aurora in equatorial.
You can
So
answer.
anyone would like to give a try?
Also. Yeah. So, Marcus, Ryan, what they say is that aurora seen in the North Pole, South Pole, Norway, Australia, Argentina, can it be seen in Singapore, in KL?
I don't think so,
Okay, why you say so?
because it can only be seen on the north and south.
I know, but that's a statement. We want you to explain your statement. Why cannot be seen in equator? Explain it. Never mind, Ryan.
I believe it has to do with the magnetic field of the Earth and how it is to a certain degree stronger in these north and south poles, and that affects the solar winds, causing the aurora.
So why cannot be seen equator according to you? Why?
Because the magnetic fields at the equator are not as strong as in the north and south poles.
Okay, I just answered this. I also, many years ago, we started astronomy. I assumed the same thing that Ryan and Marcus said. But I was surprised. 1992, Sky and Telescope magazine, I subscribed. Hey, they saw aurora in Singapore. Bright aurora, took picture. Why? The sun was very active that year. Remember, the sun has an 11-year cycle? 11 year. What do you mean by active? More solar wind, more flash, more activity. So will affect the Earth's geomagnetic environment, you see. So in normal solar activity time, the sun's energy, solar particle, electron, proton, and so on, will affect the polar region only, all right? But do you know that the Earth is round, the Earth's magnetic field will go into space, go into space and come back to the north. It seems that what happened is the charged particle from the sun, the electron, proton, can hit one of the magnetic line and can something like what you call synchrotron motion. It can go around the magnetic line from the north pole can go to the south. So imagine you're near equator, you see actually the electrons are flying from the north to the south and go back and very fast, But during the time the sun has low activity, so the aurora was from the polar region, Norway, Siberia.
Oh yeah, interrupt a while. Maybe Ryan, can you stop sharing because we have a very strong echo.
Your sound.
Yeah.
Mute your mic.
Is
Mute
it
your
better?
All right.
Okay.
Yeah.
So what happened is this is the Earth law. So when the sun is very active, the aurora can spread because as I said, it will make all the oxygen and nitrogen molecule in the upper atmosphere porous. So it will spread from Norway to Siberia, to Mongolia, to Himalayas, to Thailand, to Malaya, to Singapore, and the south also. So they have seen it. All right. So for us, so basically like that. What I understand is that Singaporean saw it on his camera, not by eye. So it's like this. You put your camera, imagine your eye cannot see aurora, but imagine you go to Norway, and then you put your camera, you don't see it because not so active, but you take long exposure, you can see. I think some years ago, I think more than 10 years ago, Mr. Teo, our member from Penang, now he's staying in Klang Valley, he came back from Nepal. And he showed me a picture of Himalaya, the what they call this, Mount Everest, and above you have the star, and then you see the pinkish light. And then he was surprised. He said his own eye don't see anything. He asked me what was the light. I couldn't answer him. Later on, he called me another time. He said that was aurora. He confirmed aurora in Nepal. So I cannot see, but you take longer exposure, maybe half an hour on the own, you can get the aurora. So aurora has been captured in the equator, but rare. But if you ask me, can we see the aurora in the equator now? I'll say, sorry guy, the sun is now very quiet. This is solar cycle number 25. Remember, since solar cycle 23rd, getting less active compared to the earlier cycle, 24, the last cycle, very inactive. 25, beginning, even less active. So being less active, you cannot see aurora in the equator now. All right. So actually now, because the solar cycle is weakening, the Earth's weather is actually cooling, less effect. So sorry, there's no global warming. It's actually global cooling. Since the cycle number 24, the last cycle, and now beginning of cycle 25 is cooling. We have been getting calls from KL where people said, do you think that there will be, we can see snow in Cameron Highland? I said, cannot be lah. Yeah, maybe cool, but you observe in the Malaysian newspaper that in Cameron Highland it's very cold, In Hanoi, in northern Vietnam, very cold. So it's actually cooling. So some people say that they predict that if the sun goes on, maybe I find that it's a kind of exaggeration. Mini ice age coming. Mini ice age, because the sun is getting less and less active. Yeah, okay. So that's a long answer. Any other question, Lai?
No.
Lai,
That's
you
all.
can ask a question. Yes.
That's all. And I think because it's quite late now, so I think maybe
One question for Marcus. Marcus,
Yeah.
your February the 6th, how did you get the circular picture? Northern winter. You
I
didn't
already explained.
I didn't get it.
Okay.
Go show the picture. Present your picture. Present now. How did they get the circular picture?
Okay, so here, the author, he used a panoramic camera like the one on Perseverance. He captured it, and then he captured a few of it, and then he captured a panoramic picture, and then he used like a photo editing software to combine both ends.
No, not combine both end. One end of it joined to the other end, like the head of a snake.
Yeah, that's what I meant.
Yeah, but people don't get it if we don't explain it clearly. Okay. So, Lai, anything else?
No, I think that's it. We call it a session. Maybe we stop now.
Maybe you can stop the session officially, but then we have a short chat among ourselves.
Yeah. So once again, thank you all of our audience, ladies and gentlemen. Thank you for joining us tonight, having a good patience with us. Today's airport is slightly longer than the previous one. So we hope to see you next month, the last Saturday of next month for the next APOD session. And please follow our Facebook page, Instagram or YouTube channel to get updated on upcoming events by ASP. So once again, thank you everyone. Have a good night. Thank you, Dr. Chong. Thank you, Ryan, and thank you, Marcus.
Thank you.